Welcome back. This lesson we're just going to be looking at one-to-one functions and implied domains. So if you remember when we talked about function notation, we talked about the vertical line test. So if we have a graph look like this, anywhere we drew a vertical line, if it only crossed it once or at 0 times, then we could say it is a function. And if it crossed it more than once, we said it wasn't a function. A one-to-one function is any function that has one unique x value for every y value. Function we said had every x value had a unique y value, and so we had a vertical line test. So a one-to-one function to have a unique x value means that it can't have two x values for the same y. So if we draw a horizontal line, we can't cross it more than once. So if we look at this graph here, if I draw horizontal lines, now this graph isn't drawn too nicely, but if it crossed it more than once, it wouldn't be a one-to-one function. So let's have a look at a few quick examples. So let's look at these four graphs here, and let's say I had one like that. This. Okay. So if I asked you which of these are one-to-one functions, the first thing you do is check with your vertical line test and go, yep, passes that, so it is a function. However, I cross it here, oh, so that is not one-to-one. All right. If it fails a vertical line test, so this one passes, happy days. Vertical line test doesn't cross more than once, so this is a one-to-one. Now if it fails the vertical line test, straight away it's not a function, so I don't even have to worry about doing the horizontal line test. If I did this first and go, oh, hang on, it's one-to-one, it's not a function because it fails the vertical line test, so not a function. So if it fails the vertical line test, don't even worry about the horizontal. Just keep going to the next one. Oh, fails it, so there it is not a function. Or it's not a one-to-one function either. It's neither. Okay? So if it passes the vertical line test, it is a function. If it passes the horizontal line test, it's a one-to-one function as well. So it passes both. So for one-to-one, think horizontal line test. So that's our one-to-one. Okay, and the second thing you're going to see in this chapter is implied domains. Now we've talked about what the domain is when we're giving functions with a restricted domain, ask you to sketch, or giving you a sketch, ask you to find the equation or state the domain and the range. If there's nothing stated, so take these three examples here. If you're asked to state the implied domain, it's asking for what values of the reals will make this equation work or will work inside this equation. So if we look at the first one, let's just number these 1, 2, and 3. If we look at equation 1, we have y equals 1 over the square root of x. Now, we know when we've got a fraction, we cannot divide by 0. So the denominator cannot be 0. So therefore, straight away, I know that x cannot equal 0. And I also know down here, if I put a negative inside the root sign, I'm going to not get a real number. So this tells me that x must be a positive whole number. Not a positive real number. Doesn't have to be whole, it can be decimal places, but as long as it's greater than 0. So this here, the implied domain would be from 0, not inclusive, to infinity. Or we could just write it as x belongs to the positive reals. Okay? Both of these are acceptable answers, just two different types of notation. If we look at the second one, equation 2, we have y equals 3 minus 2x squared. So if I look at the x and go, well, what numbers could I sub in here? I can sub in a negative number, and I'm going to get an answer for y. I can sub in a positive, I can sub in 0, I still get an answer. There is nothing that I can sub into x here that will stop me from getting an answer for y. So the implied domain is just all the reals. And lucky last one, y equals the square root of x minus 2. So we know that x minus 2, right, it can equal 0. Square root of 0 is 0, that's fine. So the point 0 is 0. But if I have the x is 0, this root sign is going to be a negative 2, isn't it? So inside this, the root sign can be 2. So we'd say here, well, therefore, x minus 2 can be, or must be greater than or equal to 0. So when I rearrange that, therefore, x must be greater than or equal to positive 2. So how do I write that in my notation? I can say the implied domain, or x just belongs to 2 to infinity. and I've got a square bracket because it can equal positive 2. Okay, so if it's the implied domain, you're just asking for what real values can x work in this equation, or will it give us a y value? Okay, if it's a linear graph or a parabola, we can see that most of the time we're going to have x belonging to the reals. If you've got a root sign, you know that you can't have a negative inside a root sign, or if it's a hyperbola, truncus, anything with a x in the denominator, you know the denominator itself can't be 0. So you go, what x values would I sub in here? That'd give me a 0. Or for the root sign, what x values would I sub in here that I end up getting a negative in there? Okay. All the best this chapter. Hopefully there's nothing too strenuous in there for you.